everyone, and welcome to Unit 2 of Calculus. In Unit 2, we will be talking about derivatives, which helps us further explore figuring out IROC at any point. Now, if you recall, when we were working with limits helped us figure out that equation to get the IROC at any point. And what derivatives does is, instead of going through all that process of having h tend towards 0, with derivatives, it gives us the equation. For this particular part of the video, we're going to refresh our mind with the exponent law. If you need a little bit more refresher, go ahead and click on the video that explores exponent laws. It's very important for you to understand it in order to be able to do derivatives properly. And if you recall exponent law 100%, just fast forward where it talks about the power rule. I had 4 or 7 r to the power of 5 times 3 r to the power of 2 over 8 r to the power of 4. How would we go about this?
So we'd first do the numerator.
Okay.
So that'd be 21 r7.
Good.
Over 8 r4.
Yeah.
And now we just divide 21 by 8.
Okay, we're going to keep it as a fraction because we can't simplify it.
So it'd be 21 by 8 and then subtract the exponent, so that'd be 21 over 8 r3.
Let's say we had root x times cube root x to the power of 7 over root 2x cubed. How would we go about this?
So we'd first multiply root x times cube root x.
How do we do that?
I forgot.
Okay, so I'm going to make it a little bit easier by changing everything to have an exponent. So this will be x to the power of 1 over 2, x to the power of 7 over 3, 2x cubed to the power of 1 over 2. So far, so good?
Yeah.
Which then will be x to the power of 1 over 2 plus 7 over 3 minus 3 times 1 over 2 over 2 to the power of 1 over 2. Does that make sense?
Yeah.
And this will get simplified to x. We need a common denominator, which will be 6. 3 over 6 plus 14 over 6 minus 9 over 6 over root 2. So far, so good?
Yeah.
And what is 3 plus 14?
17.
And what's 17 minus 9?
8.
8 over 6 root 2. We could simplify that. That becomes 4 over 3 over root 2. Now, we don't like the root 2 there, so we're going to multiply both numerator and denominator with root 2 because we need to rationalize it.
Yeah.
And that will become root 2 cube root x to the power of 4 over 2. Because it's x to the power of 4, we could simplify it as root 2x cube root x over 2. But if you had it like this over here, I would still give you the point.
Okay.
Okay? Any question? All right, I hope those examples helped refresh your memory of how to apply the exponent law. Now we're going to dive right into the power rule. Good luck, everyone. If I had f of x equals x to the power of 3, then the derivative of this is going to be 3x to the power of 3 minus 1, which means 3x to the power of 2. This over here is my final answer.
Okay.
Any question?
No.
Okay. Now, to make it a little bit harder, let's add a coefficient in front of it. Let's say I had f of x equals 2x to the power of 3. Now, to get the derivative of this, I still bring the exponent down, but it will be multiplying with the 2. And then I have x to the power of 3 minus 1, which now I have 6x squared.
Okay.
Any question?
No.
Let's try another one. Let's say we had f of x equals negative 3x to the power of 7. So the derivative of this is going to be negative 3 times 7x to the power of 7 minus 1, which is negative 21x to the power of 6. So any questions with any of these here?
No.
So all of these